Let's see chapter 3, end of chapter exercise solutions. First question, convert the following rational number in the form of a terminating decimal or non-terminating decimal and repeating decimal, whichever the case may be, by the process of long division. So you know numerator is the dividend and denominator is the divisor. So we need to take dividend and divisor. So doing long division, we cannot 3 is dividend is less than divisor, so keep a dot, include a 0, then also we cannot divide. So whenever we cannot divide, we need to put a 0 in our quotient. Now we are having one more, you can add one more 0. 6 times 50 is nothing but 300, so remainder is 0. The decimal part of 3 by 50 is nothing but 0.06. What type of decimal is this? This is the terminating decimal. Now look at the next question. Here dividend is 2, divisor is 9. So when we are performing the long division, numerator inside, denominator outside. Again our divisor is greater than the dividend. So keep a dot, include a 0. Now 20, 2 times 9 is 18. The remaining 2, again we can include one more 0. Again 2 times 9 is 18. So 2, it will goes on. We will get remainder 2, then 20, 18, it will goes on. So decimal part of 2 by 9 is nothing but 0.22222 etc., which means 2 by 9 is equal to 0.2 bar. So this is a non-terminating recurring decimal. We cannot terminate the decimal. The same number repeated there. So this is called non-terminating recurring decimal, because same digit repeated here. So non-terminating recurring digit. So next question, prove that root 5 is an irrational number. Here we need to, you know very well, root 5 is a irrational number. How to prove mathematically means we have to go with the contradict way. What is the contradict way means? We're going to assume root 5 is a rational number and we are checking whether it is accepting all the conditions for the rational number. If it is not accepting all the conditions for the rational number, then we can conclude it is not a rational number and it is an irrational number. So for what we do, we're going to assume. So assume that root 5 is a rational number. So what is the condition for our rational number? When root 5 is a rational number, it can be written in the form of P by Q, and the condition for P and Q are P by Q is in the lowest form, which means lowest form means no common factor for P and Q. It should be there in the lowest form, or we can say the P and Q both are co-primes. P and Q are integers. They are co-primes, okay, and the very important condition, Q is not equal to 0. So these are the conditions for a rational number. When a rational number can be written in the form of P by Q, definitely P and Q are integers. Then P by Q is in the lowest form, which means P and Q should not have any common factor and the denominator should not equal to 0. Denominator equal to 0, then it is a indeterminate number. We cannot find the value for the number. Now what to do? We're going to squaring on both sides. So what will happen? Root 5 the whole squared is equal to P squared by Q squared. You know root 5 the whole squared, the square root and the square will get cancelled. So 5 is equal to P squared by Q squared. When you are transposing your Q squared to next side, you will be getting P squared is equal to 5 times Q squared, which means what this shows you? This shows that P squared divisible by 5. Okay, so P also divisible by 5. That means P, we can write P is equal to 5 times any integer, say A, B, C, D or K, any integer. I am going to take, that is nothing but A. I am going to take an integer A. That is 5 times A. A is a integer. Any integer. So I got 5 is equal, P is equal to 5 times A, which means my numerator is having a factor 5. Let's check the denominator. Look at here, take this equation as your first equation. Now substitute P, that is substitute P in 1. So what you can get here, 5A the whole squared is equal to 5Q squared. So when you are squaring, 25A squared is equal to 5Q squared. Both the sides 5's multiples are there, so you can cancel it. 5 one time, 5 5 times. So when you are cancelling, 5A squared is equal to Q squared, which means 5Q squared, which means Q squared is divisible by, okay, divisible by 5. So what it shows? This shows Q squared is divisible by 5 and Q is also divisible by 5. That means you can write Q is equal to 5 some other integer, 5B, which means B is any integer. So we got P, here look at here, we got, so see I am going to highlight it. Look at here, P is equal to 5A and Q is equal to 5B. What does it means? P and Q are having a common factor 5, which means P and Q are not in the lowest form. Both are having common factor. They are not co-prime numbers. Okay. So what to write? P and Q are not in the lowest form. They are not a co-prime numbers. So our assumption is wrong. What is our assumption? We are assuming that root 5, what is our assumption? Our assumption is root 5 is a rational number. Now our assumption is wrong. Assumption is wrong, which means root 5 is not a rational number. Root 5 is an irrational number. So root 5 is an irrational number. Okay. Now, next question. Convert the following decimal number into the P by Q form. So, look at here, the first question, 12.6. You can see only one digit. So, this is terminating decimal. Only one digit is there. You can multiply and divide this by 10, which means 1260 by 10. After a decimal, after one digit we need to keep a dot, means 126 by 10. Then we need to get a lowest form, that is our P by Q form. So here 2 is common. 5 times 6 and 3, 63 by 5 is a P by Q form of 12.6. So only one digit we can write, that as nothing but divided by 10. If 2 digits are there, divided by 100. 3 digits are there, divided by 1000. Now look at here, 4 digits. 1, 2, 3, 4 digits are there. So how to write? 0, our decimal part, divided by 4 digits. 4 zeros are there. And look at here, before the number, the 0 is there, no value for that 0. So it can be written as 120 by 10,000. So we can reduce it. 0, 0 can cancel, and 12 by 1000 is nothing but 500. When we are reducing this by 2 table, 506, once again 250 and 3, So the decimal part of the given number 0.0120 is nothing but 3 by 250. Look at the next question. What is that? 3 point third subdivision 3.0525252 etc. terminating decimal. Here one decimal is non-terminating one and two decimals are two decimals are repeating. One is non-repeating, another two repeating decimals. So take given number as 3.05252 etc. This is our first equation. Now we need to make our decimals are same. If we are getting after decimal point 525252 means easily we can cancel the decimal part and easily we can get P by Q format. For that what we are going to do, first we need to move this here and the decimal should move here. Then we will be having two type of numbers with the decimals 525252 repeating decimals. So multiply first digit because first equation here 3 digit was 0 5 2 3 digits are there. Then we are having the first repeating number. So multiply our first equation with 1000. It will give 1000 x is equal to 3052.5252 etc. The same first equation if we multiplied with 10 means we can move one digit right hand side. Right hand side. So 10x is equal to 30.5252 etc. While we are subtracting these two equations, we can remove our decimal parts easily. So all the numbers get cancelled. Only we will be having the integral part. So easily we can get P by Q format. 2203. Here 1000 minus 10 is nothing but 990x. So x is equal to 3022 divided by 990. While we are reducing this because the lowest form of a number is the P by Q form. So when we are reducing this by 2, 4 times 8 remaining 1, 9 times 18 remaining 1, 5. Then this one 1 time remaining 1, 5 times 1, 1 is equal to 1511 divided by 495. So our x is nothing but 3.052 bar, which is equal to 1511 divided by 495. So look at the next question. That is here the digit is the decimal is, this is the number 1.235 bar is nothing but 1.23535 etc. So here also one non-repeating decimal and two repeating decimals are there. So the decimal part should move 3 digit here and it should move 1 digit here. So x is equal to 1.23535 etc. is the first equation. So making our decimal parts are same. We are multiplying first equation with 1000 because 1000 x is equal to 1235.3535 etc. Then again we are multiplying first equation by 10. So 10x is equal to 12.3535. Now we made now our decimals are same. So when we are subtracting these two, when we are subtracting the equation, easily we can cancel the decimal parts. Only integral parts are there. With that integral part, we can find the answer. 1000 minus 10 is nothing but 990x is equal to 5 minus 2, 3 and 2, 2, 1. So x is equal to 1223 by 990. Already it is there in the lowest form, so no need to reduce it. So 1.235 bars p by q format is nothing but 1223 divided by 990. This is the p by q form of the given non-terminating and recurring decimal. Next number is, so here we are having only the repeating decimal, no non-repeating decimal, 2323 etc. like this. So take x is equal to 0.2323 etc. is the first equation. We need to see immediately after the decimal point, immediately the repeating decimal is there. So only one multiplication is enough. First equation is multiplied with 100. We will be getting 100x because two decimals are repeated over here. 100x is equal to 23.2323 etc. And as it is, write x because there also the decimal 2323 etc. So when we are subtracting this two, easily we can cancel the decimal part. 2233, 2233, everything cancelled. Only we are having integral part. So 23 in the right hand side, then 100 minus x is 100x minus x is nothing but 90x. So x is equal to 23 by 90 is there in the lowest form. So 0.23 bars. P by Q form is nothing but 99, not 90, 99. So 23 by 99. This is the P by Q form of 0.23. So next 0.25, 2.05 is the next number. So only one part is repeated here, repeated decimal, and one non-repeated. So let's take x is equal to 2.0555 etc. is our first equation. Now we need to move our decimal to here as well here, then only we can make our decimals are same. So 1 into 2 digits 100. So 100x is equal to 205.5555 etc. Then 1 into 10 is equal to 10x is equal to 20.555 etc. While we are subtracting these two equations, cancel, 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 all the decimals are cancelled. So 5, 8, 185, this side here 9, 90. 90. So x is equal to 185 by 90. We can cancel this this with 5 table. So 18 times this one 3 7. So 37 by 18. X is equal to 37 by 18 means 2.05 bar is equal to 37 by 18. The P by Q form of 2.05 bar is nothing but 37 by 18. So the next number 2.125555 etc. Then here only one repeated digit, two non-repeated digit. Let's take x is equal to 2.12555, the first equation, etc. is the first equation. Now our duty, we need to move this here, so 3 digits, and we need to move here 2 digits. So 1 into 3 digits means 1000. So 1000 gives 1000x is equal to 2125.5555 etc. And first equation into two digits, two decimals means with 100. So 100x is equal to 212.555. Now we arranged our decimals. So when we are subtracting, all the decimal will cancel. Only we are having integral part. 3191. This side 990, 900 x. So x is nothing but 1913 divided by 900. So our decimal is 2.125 bar is equal to 1913 divided by 900. This is the P by Q form of the given number 2.125 bar. So again here 3.125 bar, the same 3.125, two non-repeating decimals and one repeating decimal here. So we need to move 3 digits and 2 digits. Let's take the given number as x first one. So 3 digit means when we are multiplying this with 1000x is equal to 3125.55 etc. Then 2 decimals means multiply this with 100. 100x is equal to 312.555 etc. And subtract and cancel the decimal part. Then subtracted 3, 1, then 8, 2, so 990 x. So x is nothing but 2813 divided by 990. So it is there in the reducible form, lowest form, no need to reduce it. So we cannot reduce. Already that is there in the lowest form. So this is the P by Q form of the given number. Here all the 4 decimals are repeated over here. So easily we can do all the 4 decimals. This is nothing but 2.1625 to 1625 etc. So 3 digits and we need to move here 2 digits. So 1 into 3 digits means 1000. So 1000 gives 1000x is equal to 2125.5555 etc. And first equation into 2 digits, 2 decimals means with 100. So 100x is equal to 212.555. Now we arranged our decimals. So when we are subtracting, all the decimal will cancel. Only we are having integral part. 3191. This side 990, 900 x. So x is nothing but 1913 divided by 900. Let's see the next question. Locate the following rational number on the number line. Now how to locate it? So 3 decimals are there. Now look at 0.5 lies between which 2 decimals? So decimal by decimal we can check it. Now look at here, look at the first 2, this 2 digit, that is 0.5 lies between 0 and 1. 0.5 is in between 0 and 1. Let's draw this in our number line. take a line. Look at here. If suppose this is number, my number line means I can divide 0 to 1 into 10 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, which means 0 after 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9 and 10. That is nothing but 1. Now 0 0.5 is here, 0 0.5. Now the 0 0.5 and 0 0.6, in between these two our next digit is there, that is 0 0.53 is lies in between 0 0.5 and 0 0.6. So what I going to do, I going to enlarge 0 0.5 and 0 0.6. In between 0 0.5 and 0 0.6, I am going to take 10 equal parts again. Say, look at here. See, this one enlarged like this and 0 0.6 I am going to place here, which means this is 0 0.5. 0 0.5 is nothing but 0 0.50. This is nothing but 0 0.6, nothing but 0 0.60. Now 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is this? 0 0.51, 0 0.52. This is 0 0.53, 0 0.54. This is 0 0.55, 0 0.56, 0 0.57, 0 0.58, 0 0.58, 0 0.59 and 0 0.60. Then now our 0 0.53 is here. Our next decimal 0 0.532 lies between these two. That is 0 0.532 is in between 0 0.53 and 0 0.54. That is 0 0.530 and 0 0.540. In between that 0 0.523 is there. So once again we will take a number line. Now in this line we are going to show the parts in between these two. That is zero 0.53 and 0 0.54. So in between this two only our required number. So this is nothing but 0 0.530. This is nothing but 0 0.540. So in between 10 parts. 1, 2, 3, 4, 5, 6, 8, 9 and 10. So this one 0 0.531, 0 0.532, 0 0.533, 0 0.534, 0 0.535, 0 0.536, 0 0.537, 0 0.538, 0 0.539 and 0 0.540. So exactly our number is this one, 0 0.532, which is in between 0.53 and 0.54, which is here, and these two numbers in between 0.5 and 0.6, which is here, and 0.5 and 6 in between 0 to 1, which means 0.532 can be written 532 divided by 1000. So 0 to 1 will divided into 1000 equal parts, then we can show the number exactly. Now look at the next question. So here this is again an repeating decimal, that is 1.15 bar. So only one decimal is repeated here, that is 1.15155, etc. We can consider this the rounding of 1.16. Now 1.16 first decimal is 1.1, which is lies between 1 and 2. So let's see that in our number line where it should be. In our number line it is, excuse me, take a number line, 1 and 2, 1 to 2, the numbers. So in between 1 and 2, 10 parts. First part 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9 and 2. Take the number line. So now what we're going to do, we're going to enlarge this one. This is the place for 1.1. So in between 1.1 and 1.2, there are 10 parts. Here 1.1, here 1.2. So this is 1.11, 1.12, 1.13, 1.14, 1.15, 1.16, 1.17, 1.18, 1.19. So exactly our number is here. So which that is in between 1.1 and 1.2. Like this we can find the number in the number line. Now next, find 6 rational numbers between 3 and 4. So easiest method to find rational number between two numbers, making the denominator as same. So both are whole numbers. So when we are making this as rational number 3 by 1 and 1 by 4 by 1, we need 6 rational numbers. So 6, always whatever the number is given here, take one more number. Suppose for example, if I am taking some other number, suppose I am taking 4 as common number and making my denominator as 4. So what can I get from here? 12 by 4 and 16 by 4. So how many numbers are there? 13 by 4, 15 by 4. Only two numbers I can get. Only two rationals in between this I can get. So what to do? What is the given number? One number more. If 6 numbers are given, 6 rational number you need to find means at least 7. Multiply the given number with 7 or 8 or 9 or 10, any number. So I going to multiply this with 7. 3 into 7, 1 into 7 and 4 into 7 and 1 into 7. So 3 sevens are 25 by 7 and 28 by 7. Now how many numbers? 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7. So 1, 2, 3, 4, 5, 6 numbers. We got 6 numbers. So how many numbers they are asking? More than one. You need to take a number more than one. Then make a common denominator. Then find the numbers in between that. Now look at the next question. Find rational number in between 2 by 5 and 3 by 5. So find a rational number means at least with 6 we need to multiply. Minimum 6 or else 10, whatever it may be. So we will take for 6. Tip 6 is the common number. 2 into 6 by 5 into 6 and 3 into 6 by 5 into my common factor is 6. So 12 by 30 and 18 by 30. So in between I can get 13 by 30, 14 by 30, 15 by 30, 16 by 30, 17 by 35 numbers. So exactly 5 rational number in between 2 by 5 and 3 by 5. These are the numbers. Next, find 5 rational number between 1 by 6 and 2 by 5. Same way, 5 rational numbers are there, but here the given number already unlike fraction. So making this as like means we need to multiply with LCM. 6 and 5's LCM is 30. So while we are making that as common denominator, multiply this with first with 5 and second with 6. 5 by 30 and 12 by 30. So here itself we are having many numbers. 5 by 30 and 12 by 30. 6 by 30 is one number. 7 by 30, 8 by 30, 9 by 30, 10 by 30. These are the 5 numbers. Some other numbers, 11 by 30 also is there. So 5 number we can take. Next question. If x plus 3 plus x plus 5, x by 3 plus x by 5 is equal to 16 by 15, find the rational number x. So find the LCM. 15 is the LCM. 3 and 5 LCM is 15. So cross multiplication we will be getting the numerator. 5x plus 3x is equal to 16 by 15, which is nothing but 8x by 15 is equal to 16 by 15. We can cancel 15 and 15. So 8x is equal to 16. X is nothing but 16 by 8. So our x is 2. X is equal to 2. The rational number here is nothing but 2. Let A and B two non-zero rational numbers such that A plus 1 by B is equal to 0 without assigning numerical value. Determine whether AB is positive or negative. Justify your answer. So take LCM. When you are taking LCM, B is the LCM. So AB plus 1 is equal to 0. Transposing this to this side, AB plus 1 is equal to 0. Now transposing plus 1 to next side minus 1. So our AB is nothing but negative. AB is a negative number. Next, a rational number has a terminating decimal expansion whose last non-zero digit occurring in the fourth decimal place. Show that such a number can be written in the form of p by 10 power 4, where p is an integer not divisible by 10. It is necessary that the denominator of this rational number, when written in the lowest form, is divisible by 2 power 4 and 5 power 4. Give reason. So let's take a number. Suppose x is equal to 0.2360. When I am taking a decimal like this, how can I write this in the p by q form? 2360 by 10,000. Say last digit is 0, which means the numerator can divisible by 10, means we can cancel this. So our x is nothing but 236 by 1000, which is not 10 to the power 4, which is 10 to the power 0. So that the condition is given here. The non-zero digit is there in the fourth place. So 2369. Suppose I am going to take this number. Now non-zero number there in the fourth place. I can take this number as 2364 by 10,000. So denominator is in the form of 10 to the power 4. When a numerator is divisible by 10, means you cannot get denominator is in the form of 10 to the power 4, which is nothing but 2364 divided by 10 power 4. And when you are getting a lowest form, so when I am reducing this with two table, 8 times 2, then again 5000. Once again I am reducing this with 2 table, 5 times 9 and 1 divided by 2500. So which means the lowest form cannot show the denominator is in the form of 2's power 4 or 5's power 4. It is not necessary. When you are dividing this, you will be getting non-zero digit there in the fourth decimal. Next, without performing division, determine whether the decimal expansion 18 by 125 is terminating or non-terminating. If it is terminating, state the number of decimal places. 18 by 125, you know very well 125 is nothing but, look at the long division, 125. 5 times 2, 5 table, 2 times 25 times, again 5 times. So 18 by 5 cube. There is no common factor in the numerator and denominator. Already that is there in the lowest form. So 18 by 5 cube. So denominator is in the form of 2 by something or 5 by something or 2 power m into 5 power m, means then we will be having terminating decimal. Terminating decimal. So our question 18 by 125's denominator is in the form of 5 over 3. So this is nothing but terminating decimal number. A rational number in its lowest form has denominator 2 power 3 into 5. How many decimal places will its decimal expansion have? Explain your answer. So whenever we are having decimal place, how we will say? Maximum of 2's power, 5's power. So here 2's power is 3 and 5's power is 1. So what is the maximum power? 3. So we will be having 3 decimal. Maximum of this is 3. So therefore 3 decimal places. Okay, so decimal places, you no need to multiply and find, just to see the powers. Maximum of 2 power and 5 power, which is maximum, that many decimals we can get. Next question, let a is equal to 7 by 12 and b is equal to 5 by 6. Express both a and b is in the form of k1 by m and k2 by m, where k1, k2 and m are integers and k2 minus k1 is greater than 6. Using the same denominator m, write exactly 5 distinct rational number lying between a and b, keeping an integer numerator. Explain why the condition k2 minus k1 is greater than n plus 1 is necessary to find n such rational numbers between the two rational numbers a and b using this method. So first, see, 7 by 12, if I am making this also by 12 means I'll be getting 10 by 12. So now 7 by 12 and 10 by 12, how many numbers in between that? 8 by 12 and 9 by 12. Look at here, m1 is equal to 7, m2 is equal to k1. k1 is equal to k1, k2, not m1, m2, k1, k2. So here k1 is 7, k2 is 10. Okay, this is k1, this is k2 and m is the common denominator 12. So the condition k2 minus k1, what we are getting, k2 minus k1 is equal to 10 minus 7 is equal to 3, which is less than 6. So that only 2 numbers in between we are getting. Suppose I am multiplying this with some other number. So a is equal to 7 by 12. So, I'm going to multiply this with 4 and this with 4. So I will be getting 28 by 48. Then b is equal to 10 by 12 into 4 into 4 is equal to 40 by 48. Now 28 by 48 and 40 by 48. 40 by 48, many numbers are there. Now look at here, k1 is equal to 28, k2 is equal to 40, our m is nothing but 48. Now k2 minus k1 is equal to 40 minus 28 is equal to 22, 12. So that is 12 is greater than 6, so that we are getting so many numbers. Now our k2 minus k1 minus 1 is greater than n, so that we are getting k2 minus k1 is greater than n plus 1. 14th question, 3 rational number x, y, z satisfying x plus y plus z is equal to 0, xy plus yz plus zx is equal to 0. So two conditions are given, x plus y plus z is equal to 0 and xy plus yz plus zx is equal to 0. These are the two conditions given. Show that the rational number x, y, z must be simultaneous zeros. So take the identity x plus y plus z, the whole squared is nothing but x squared plus y squared plus z squared plus 2xy plus yz plus zx. Now replace the given condition here. 0, left side 0 squared is equal to x squared plus y squared plus z squared plus 2 times 0, because these twos are 0, which is x plus y plus z is equal to 0 and xy plus y plus yz plus zx is equal to 0. When we are replacing that here, you will be getting x squared plus y squared plus z squared is equal to 0. So when sum of square of three integer will become 0 when x is equal to 0, that is x squared is equal to 0, y squared is equal to 0, z squared is equal to 0, and x is equal to 0, y is equal to 0, z is equal to 0. So that we are getting 0 as the answer. So x, y, z must be simultaneous zeros. Look at the next question. Show that the rational number a plus b by 2 lies between the rational number a and b. So suppose a is less than b, first case. I'm going to add a both the sides. A plus a, which is less than a plus b. So I'm going to get 2a is less than a plus b. Nothing but look at the next question. 15th question. Show that the rational number a plus b by 2 lies between the rational numbers a and b. Let's take a is less than b. Add a on both the sides. A plus a is less than a plus b, which means 2a is less than a plus b. While dividing both the side by a 2, I am getting a is less than a plus b by 2. So this is one result. A is less than a plus b by 2. Suppose I'm going to take the next case, b is less than a, which means I'm going to add b on both the side. B plus b is less than a plus b. Then 2b is less than a plus b. Dividing b on both the sides, b is less than a plus b divided by 2. So a is less than b plus a is less than a plus b by 2, and if suppose b is less than means so b is less than a by 2. Now in the first case I going to add b on both the side, that is a is less than b means adding b on both the side, b plus b. Then a plus b is less than 2b, which is nothing but a plus b by 2 is less than b. So a plus b by 2 is lies in between a and b. Here in this case, suppose I am adding a on both the side, a plus b is less than a plus a plus b is less than 2a. So a plus b by 2 is less than a. So when a is less than b or b is less than a, whatever it may be, a is less than a plus b is less than, so a is less than a plus b by 2 is less than b. So a plus b by 2 is lies in between a and b. So look at the next question. Find the length of the hypotenuse of the right triangle in figure, which is referred as the square root spiral. Look at the first triangle. See, this is our first triangle. So this is first triangle means look at the 90-degree. So both the sides of 90-degree, nothing but 1 unit and 1 unit. Suppose I am going to name it O A B. So triangle OAB, one side is 1 and another side is 1 unit. So I can find the hypotenuse. You know the Pythagoras theorem. Pythagoras theorem is nothing but sum of squares of the two sides, nothing but hypotenuse squared. So first triangle, first triangle hypotenuse is equal to square root of sum of squares of two sides, which is nothing but root 2. So this is root 2. Now the second triangle, the purple color is the second triangle. So here our right angle. So one side is root 2, another side is 1. So second triangle. Second triangle hypotenuse is equal to square root of one side is root 2, the another side is 1, which is nothing but 2 plus 1 is equal to root 3. So this is root 3. So next triangle, third triangle. So third triangle, one side is root 3, one side is root 3, another side is 1. So root 3 squared is 3, then plus 1 is equal to root 4. So fourth triangle, this is root 4. So fourth triangle, this is 1 and root 4. So fourth triangle, hypotenuse is equal to square root of root 4 the whole square plus 1 is equal to 4 plus 1 is equal to root 5. So fifth triangle hypotenuse, this is root 5. So this is root 6, this is root 7, this is root 8, this is root 9, this is root 10, this is root 11. Like that, fifth triangle hypotenuse is root 6. Then sixth triangle hypotenuse, sixth triangle hypotenuse is root 7. And seventh triangle hypotenuse is root 8. Eighth triangle hypotenuse is root 9 and ninth triangle hypotenuse is root 10. Thank you.